Hello friends, we have seen that fine aggregates and coarse aggregates, they are the main aggregates used in concrete making. The characteristics possessed by these aggregates have a great impact on the properties of concrete also. So let us see the properties of aggregates. Properties of aggregates, let us discuss this. Now, the concrete is manufactured by mixing cement and aggregates with water. We have seen that aggregates mainly provide body or volume to the concrete. But it does not mean that the concrete without aggregates can acquire desired strength. The strength of aggregates is also very important, which will be finally giving the strength to the concrete. Now, how this strength can be determined and what is the strength that is expected of the aggregates? So, the aggregates in concrete, which will be used for making roads, which will be used for making buildings, bridges, flyovers, and many more applications, whereon there will be a tremendous movement of traffic, vehicles, the pneumatic tires will be there, or the floors which will be used for the buildings, that can also have tremendous live load, dead load. There can be movement of the people as well as the materials, and hence the aggregates are required to have different types of strength. Basically, the aggregates are tested or confirmed for one strength, that is called crushing. Means when the aggregates and together with that aggregates the concrete, if it is subjected to a compressive strength, a pressure situation, it should be withstanding, and therefore we can find out the crushing value of aggregates. Again, there will be one another type of destructive force that can come on the aggregates, that is called impact. And therefore the property is also known as impact value, by which we can judge the toughness of the aggregates. And when the movement of tires on a concrete road, and then therefore the aggregates also, if that is wearing the aggregate surfaces to a lot extent, we can have a different requirement, and that can be said as abrasion. So all these are different mechanical properties of aggregates. They are called mechanical properties because there is some force and there are some resistances offered by the aggregates. So compression, then the impact of force which is dropping from certain height, and a frictional type of force or wearing and tearing of that in form of an abrasion resistance. Generally, IS 1343, different parts, part 1, 2, 3, 4, that is there to set some standards for all these values. The main tests which are carried out on aggregates, they are crushing value test, impact value test, and one more test is there, that is 10% fines. Rather, this is the most reliable, though this aggregate crushing value is most popular one, aggregate test for 10% fines is more reliable. And what is that? For roads and pavements, if the aggregates are required to be tested in 10% fines, the determination of load, how much load that can carry for making the aggregates crushed less than 10%, and that is their limit has been given also up to 10 tons, and for all other concretes up to 5 tons. So 10% fines is more reliable test, but more popular are these, the aggregate crushing value for the main strength, that is the compression strength, and these two tests for measurement of toughness and hardness test. So in case of the aggregate crushing value test, we have to have a sample of aggregates which should be in between 10 mm to 12.5 mm. Means take a known quantity of known mass of aggregates, pass it on 12.5 mm IS standard sieve and retain it on the 10 mm standard IS sieve. Whatever is there in between these two sizes, measure now the weight of it, suppose 1 kg or 5 kg, and then there is a crushing value apparatus. A machine is there and we have there the test carried out on it, compression strength of that crushing value or the aggregates is found out, and the best aggregates is supposed to be 30 to 45% crushing value, the value of which in between 30% or 45%, not more than 45%. Means the portion of aggregates which has got crushed, it should not be more than 45%. Actually that sample which is tested under crushing, finally we have to pass it on the sieve, and remaining weight of that particular remaining retained on the aggregates, that we have to measure, and then we can have the report of that test. So all these tests are described in IS 1343. The students also are required to perform experiments in the laboratory in their respective institutes, and therefore you should be very clear in understanding the meaning of that crushing value. Similarly, impact value, when a sample is there, again 12.5 mm and 10 mm, in between these two sizes the sample is to be collected. There is a mold of that machine, we have to fill that mold in a systematic manner as directed by the Indian Standards 1343, and then we have to apply the impact, or we have to give the impact in that machine. There is an arrangement, you have lifting of those two things, arms, and then suddenly you have to release, so there will be an impact on that aggregates in the mold, and then you have to see how much the crushing, or that means fine powder of that has been there. We have to measure it, and the calculations required we have to do them, and then we have to again report that impact value in percentage. So anything less than 30% is very important for road surfaces, and in other concretes maybe 30 to 35%, but less than always 45%. That is not allowed, that more than 45%, but this is again a norm which has been revised recently, and for both now the code says that 35% is the highest value. Anything which is crushed or which is having some fine powdered format in the impact, we have to have less than 35%. Then abrasion test. There is one more equipment there is a Los Angeles apparatus, drum is there in which we have to apply the aggregates, and there are certain 12 number of specified balls, and the rotations are given, revolutions are given to that, about 500, and in that process there is a friction or wearing of the aggregate surfaces, and we get powder finally. How much is that? Again, with the original weight we have to compare of the aggregates, and then we have to report that as an abrasion value. So we have toughness, we have hardness, and we have the strength bearing capacity in form of crushing value. These are called mechanical properties of aggregates. In case of fine aggregates, we should not have that much concern for strength, because fine aggregates are ultimately filling up the gaps between the coarse aggregates, and therefore coarse aggregates are the main things they are expected to carry the strength. So here we have seen the strength. So let us see the next property. Now this is also very important property of aggregates. We have to find out the specific gravity of the given aggregates. The specific gravity, as you all know, the ratio of mass of solid material of aggregates to the mass of water in standard conditions. This is the specific gravity. But many times in our coarse aggregates, fine aggregates, we have also voids or pores which may be taken into the calculation of mass, and in that case we have to define therefore two types of specific gravity in the reference of aggregates. So one is called apparent specific gravity and other is called absolute specific gravity. You can know that the absolute specific gravity will not permit the inclusion of voids. In case of apparent specific gravity, okay, the pore spaces are also taken in the measurement of mass or volume. Many times many people also refer to mass, many people also refer to volume of aggregates and volume of water. The specific gravity value of aggregates is ranging from 2.5 to 2.85. Now the use of specific gravity, value of specific gravity is mainly made in the mix design. When we use the concrete for a particular purpose, we have to have a strength of the concrete assured, and that is defined as a grade of concrete. So when we design the mix of the concrete, we aim at a particular grade. For that we can use the value of specific gravity. The determination of specific gravity again in the laboratory is very much possible, as the surface of the aggregates may be totally dried, or the surface of the aggregates may be wet, or there may be totally no water present inside the aggregate particle, or there may be full saturation by water inside the aggregate. So depending on these three conditions, we may say that the aggregates may be either bone dry or dry, surface dry, or we have wet also. So depending on these 2-3 varieties, we can get the sample of aggregates, and therefore we may have the mass of those in, say, a designation, suppose A, B, C. Then we can use those values for making the calculations of specific gravity of the aggregates. All this is there in the IS code 1343. Students are requested to know the details of the test procedure, conduct the test in the laboratory. Then only they can know what is the specific gravity of a particular aggregates. Now let us see one more property of aggregates. As we know, density is the ratio of mass and volume, unit volume. Similarly, density of aggregates is the ratio of mass and volume. But why it is called bulk? Because in the aggregates, again we can imagine that aggregates will not be only solid particles, there will be some void spaces, pore spaces. Particularly in case of sand, we have got that the spaces in between two particles may be occupied by some moisture also, and therefore there will be a term used bulk density more aptly in case of aggregates. Now, different factors which will be affecting on the value of density, they may be the shape of the particular aggregates, that may be the size of the aggregates, and definitely the moisture content, if at all there. Means if you calculate for the same sample of aggregates the value of bulk density in the rainy season, and the same aggregates if they are determined for the property of bulk density in dry season or summer season, you will get different values, and therefore the indication by this particular value is there that how much closely, how much densely are the aggregates packed. So that is the density, and this is very important because ultimately they are occupying that volume and they are providing the body to the concrete. Therefore, knowledge of the bulk density of aggregates is important. Again, that will be used in the mixed design. Now let us see one more property. This is generally more relevant in case of fine aggregates. So in case of sand or fine aggregates, particularly again in the moist sand or in the rainy season, how much volume is there occupied by a particular sand sample will be not referring to the exact weight content of that aggregates, because some volume is also excessively, unnecessarily occupied by the moisture content. And if we have mixed design results, suppose cement these many kgs, then sand these many kgs, then aggregates these many kgs, and if the in charge on the site, if he is not knowing what is the effect of bulking on sand, and if the laborers they are taking only those much kgs for making a mix of concrete, definitely you can see that there will be a serious error. Even if as a contractor I am asking for a material supplier to supply sand to my site, and in that tractor trolley the measurement is taken, I actually want, suppose, a particular mass of sand, that many kgs of the sand, and he says that if this trolley container is full, leveled, then you are sure that that many kgs will be delivered to you. But in case of again the presence of moisture, I am always on the losing side. I will get some less amount of sand in terms of kgs. This is the effect of bulking. So the engineer in charge should be very well versed with the bulking of sand. Now, bulking, how to determine it? A very simple experiment we can do. Take some known volume of sample in a test tube, go on adding water to it. In the initial stages, the volume will be increasing, and then at one particular point, further addition of water, you will see that slowly the volume of sand that is going down. That means if a curve is to be plotted, then that curve has to be like this. So definitely you have the effect of bulking, and generally the sands which are finer, which are medium sand, and which are coarse sand, that coarse sand is on a benefiting side for the contractor or for the project, because coarse sand have a lesser tendency to bulk than the finer sands. Fine sands always will have more bulking. So if I have to draw some curves, bulking curves, then definitely this will be the curve for fine sand, this will be the curve for medium sand, and this will be the curve for coarse sand. On this side, that axis is the moisture content, and this is the bulking. So we have the bulking effect in sand which is finer in particles, that as a more, and therefore bulking curves are plotted. There are also standards governing the sand bulking percentages. If the sand is bulking very heavily, then we should not be accepting that sand at all. So this is about the bulking of fine aggregates. Let us see one more property of aggregates, which is called soundness of aggregates. Now, it is found that aggregates, though we say that they are required to be chemically inactive, inert, but some chemicals may have their effect on it. They are not going to react with the chemicals, but the chemicals themselves, they have the effect on the aggregates. The main effect is that the aggregates lose their weight if that is not sound. If the aggregate is very, very sound, it will not have any effect of the chemical on its own. So if the aggregates come in contact with sodium sulfate or magnesium sulfate, sodium sulfate or magnesium sulfate, then it is bound to happen that they lose the weight. They give a procedure how to determine the soundness. And IS 343 1970, that limits the loss of weight in these two cases. So in case of sodium sulfate, the loss of weight should be less than 12%. In case of magnesium sulfate, the loss of weight of aggregates should be less than 18%, and that is the limit that has been set down by the IS codes. When we confirm these things, then only we can use those aggregates in our concrete making. Let us see what is called as deleterious materials in aggregates. This is easy to remember. What is the meaning of deleterious? Unwanted. That means we have seen in the introduction part also that aggregates are required to be chemically inactive, inert. If they are having some chemically active substances, then those substances unnecessarily will part the cement or water, that reaction interfere with that, and therefore they will be creating something which is not desirable. Now these unwanted materials, even if we have the natural sources or the artificial aggregates, there may be atmospheric environmental changes or environmental effects on that, and sometimes those materials get unwanted thing coated on their surfaces externally, and therefore it is always better to wash the aggregates whenever we are making concrete. That is the best solution. Deleterious materials in general for any type of aggregates should not be more than 5%. So always the limit is it should be less than 5%. It is crossing suppose 5% value, then we have to have serious monitoring of the aggregates, or we cannot directly allow the site engineer to make use of such aggregates in the concrete making. Let us see one more property of aggregates, which is known as alkali aggregate reaction. Or it is AAR. One more name is given to it as ASR. The reason being, only the silica content of aggregate has a reactivity with alkali. Alkali is there present in the cement because of, so Na2O, sodium oxide and potassium oxide, these are the two alkali contents from cement, and these will be always having a reactivity. So aggregate silica content will react with these two alkali content, and after that silicate gel gets formed, which is expansive, leading to volume increasing. So volume increases, that leads to volume increase, and therefore the concrete mass unnecessarily goes beyond the boundaries, thereby leading the cracks in the concrete. And hence the alkali aggregate reaction or the alkali silica reaction should be always controlled. How to control that? The best way is to low silica content aggregates, or they are called less low reactive aggregates. They can be used for the concrete making. And if at all that is not possible, then we have to have less alkali cement. Alkali cement content can be reduced. Even we can go for the secondary cementitious materials like GGBS or fly ash, so that the alkali aggregate reaction is controlled. One more factor which is there on this alkali aggregate reaction affecting is the temperature. Generally 10 degrees Celsius to 40 degrees Celsius. This is the range of temperature in which concreting activities should be conducted. But inside the body of the concrete, we cannot have the temperature control. It is very difficult for controlling the temperature inside the concrete. Therefore, temperature we cannot have that much under our control. But we can go for the less reactive aggregates, low alkali cement, and secondary cementitious materials. So less alkali cement, less reactive aggregate, use of SCMs, and temperature control. So these are the controlling measures for alkali aggregate reaction. So this is about the alkali aggregate reaction. Thank you.